In this video, we're going to solve logarithmic equations. The first step would be if there's anything multiplied in front, like we have in example B, you'd want to divide both sides by that. Or even before then, if there's anything added or subtracted after the logarithm, you'd want to get rid of that. But in example A, we're good to go. We're ready to change forms. So get the log by itself and then change forms. Woo! This is 3 squared equals x plus 2. 3 squared we can do in our calculator and then finish solving. So x equals 7. In example B, we would start by dividing both sides by 2. And in this case, we're probably going to end up with a decimal answer, especially since we're dealing with ln. So 7 divided by 2 is 3.5. I'm just going to go ahead and use the decimal 3.5. Now remember that ln is the same as log base e. So you could rewrite this log base e, and in fact some of you would prefer to do that. Oops, I forgot my close parentheses. Others of you would be fine just writing a little e as the base, just to remind yourself that ln is base e. Either way, we need to change forms. Woo! E raised to the 3.5 equals 3x. E is something that you can calculate. The E button is right above the ln button on your calculator. So in your calculator, do E raised to the 3.5. You should get 33.12. And then we would finish solving this. We need to get x by itself. Our final answer would be 11.04. So x equals 11.04. In example 4, in your notes, I would write that when there are more than one logarithm, you're going to need to condense first. So remember the lesson where we talked about expanding and condensing logarithms? That's 11.4, part 2. We need to condense this down to just one logarithm first. So there's plus in between these two logs. That means this will condense down to log base 6 of x times x minus 5 equals 2. So the x and the x minus 5 will come together inside the same logarithm. Now we can change forms. Woo! 6 squared equals x times x minus 5. 6 squared is 36, and we distribute. I see x squared and x in the same equation. If we have x squared and x in the same equation, we need to get one side equal to 0 so that we can factor and solve. Our favorite thing to do, factoring. We love factoring. So 0 equals x squared minus 5x minus 36. We need to factor this trinomial. Remember, we're looking for two numbers that multiply to give us negative 36 and add up to negative 5. Now, this pair of numbers was kind of tough for me. It didn't pop into my head immediately. But I thought about, to get 36, I can do 1 times 36, 2 times 18, 3 times 12, 4 times 9, or 6 times 6. That's all of the ways that we can multiply to get 36. Of these options, I need one that will somehow add up to negative 5. So it's got to be 4 and 9. So if we do 4 and negative 9, that would add up to negative 5. 4 times negative 9 is negative 36. So x plus 4, x minus 9. This means our solutions. If the first set of parentheses had to equal 0, our solution would be negative 4, because negative 4 plus 4 is 0. If our second set of parentheses had to equal 0, x would be 9. So our two solutions are negative 4 and 9. Now the one thing that we haven't talked about yet relates to the domain of logarithms. If we graph a logarithm, it has a vertical asymptote of x equals 0. All of the x values on this logarithm are bigger than 0. You can't have a negative number inside of a log. In fact, if you try in your calculator, try doing just common log of negative 2, your calculator is going to give you an error. So if we took this negative 4 and tried plugging it in right here, we'd have log base 6 of negative 4. That can't happen. We can't do the log of a negative number, so that is an extraneous solution. Now if we plug 9 in, 9 would be a positive number here, and 9 minus 5 is still a positive number, so it is absolutely fine. That answer is good. Example 5 is similar, and honestly it's a little bit more extreme than what you are going to see, but really it's not that much more. So first thing we're going to do is condense. So this is going to be log base 2, and I do see subtraction in here, so that means that there's going to be a top and a bottom. The x and the x plus 2 are inside positive logs, so the x and the x plus 2 are going to be on top inside that log in the numerator. And the 3 comes from a negative log, so that 3 is going to be in the denominator inside the log, and the whole thing equals 4. Once you have it condensed down to just one log, we need to do the log-ride and change forms. So, woo! 2 to the 4th equals x times x plus 2 divided by 3. All right, 2 to the 4th, we can calculate that. 2 to the 4th, I had to pull up my calculator, 2 to the 4th is 16. So we have 16 equals x times x plus 2 divided by 3. We undo divided by 3 by multiplying by 3. And 16 times 3 is 48. On the right side, we would have left x times the quantity x plus 2. We can distribute to get x squared plus 2x, and then get 0 on one side by subtracting 48 on both sides. At this point, I'll take this up here. We've got 0 equals x squared plus 2x minus 48. What do you suppose we need to do with this? We need to factor and solve. We're looking for two numbers that multiply to give us negative 48. Those same numbers need to add up to 2. You multiply to get the last number, you add to get the middle number. Again, this one didn't pop into my head immediately, which is totally fine if it doesn't. Think about ways to get 48. We can do 1 times 48, 2 times 24. Again, if you hear any background noise, I am sorry. 3 times 16, 4 times 12, 6 times 8. Ooh, 6 times 8. So if we do negative 6 and positive 8, if you want to get positive 2, the bigger number needs to be positive, so the 8 needs to be positive. So x minus 6, x plus 8, which means that our solutions are 6 and negative 8. Now again, we have to check our solutions because you cannot have negatives inside of a logarithm. So I'm going to write down no negatives inside logs. Okay, again, if you hear background noise, there's like large things being thrown around me. This is craziness. Okay, if I plug 6 in here, log base 2 of 6, that would be fine. 6 plus 2, that would not be negative, so we're good. 6 is good. If I try negative 8, if I put a negative 8 right here, we'd have a negative inside the log. That's no good. So negative 8 is our extraneous solution. X equals 6 is our actual solution. This example got a little screwed up when I printed the slide, but it says that ln of 3 minus x equals ln of 10. Now, here's the cool thing. ln of stuff equals ln of stuff. As long as the ln's are the same, as long as it's like ln on both sides, or if it was log base 2 of stuff equals log base 2 of stuff. As long as the logs match on both sides, the stuff is going to equal the other stuff. So what this means is 3 minus x has to equal 10. These are honestly the easiest of the equations to solve because if the ln matches on both sides, then the stuff is equal to each other. Solve that usually simple equation. So we'd subtract 3 on both sides to get negative x equals 7. Divide both sides by negative 1 to get x equals negative 7. Now you might be thinking, oh my gosh, a negative number, we can't have negatives inside a log. But if you put negative 7 in here, 3 minus a negative 7, that becomes positive, so it is fine.